Okay, so let's look at how to calculate the curvature of a space curve using an alternate formula. And the one that we're going to use is this quite interesting one, which is the magnitude of the cross product of the first and second derivative divided by the magnitude of that first derivative cubed. The example I'm going to choose is number 13, and the space curve is 0, t to the 7, and t to the 5. So we'll begin by finding the first derivative so that we can get that bottom term. And that's going to be 0, 7t to the 6, 5t to the 4. And the magnitude of that vector is going to be the square root of each of those components squared. So that's 0, 49t to the 12, 25t to the 8. And we're just going to leave it in that format for the time being. Then what we're going to then do is cube this. And I'm going to express it as a fractional power. So I'm just going to call it that. Okay, that's part of the puzzle done. Let's get the top part done now. I know the derivative. So that's going to be my new starting point. So I can now find the second derivative. It's 42 t to the 5, 20 t cubed. I can now find the cross product. So it's going to be an I, a chi, and a k. And that's going to be a 0, 7t to the 6, and 5t to the 4, then a 0, 42t to the 5, and 20 t cubed. So that's going to be so many i's, take away so many j's, plus so many k's. Well, when we cover that guy up, you get 120 t to the 9, take away 210 t to the 9. When you do the middle one, you get 0, take away 0. And the end one, you get 0, take away 0. So we are looking at negative 90 t to the 9, 0, 0. And the magnitude of the first and second derivative vector cross product is the magnitude of this. Now I can square this, add, do the whole thing, but it's not hard to figure out that that's what you're going to end up with. Positive 90 t to the 9. And I'm going to change that to 140. And that 140 is going to make this 70. So we're now going to get 70 t to the 9 there. Quick correction. That number is 140, not what I said earlier. And so 140 take away 210 is negative 70. So you get 70 t there. So the curvature is the cross product, that's this guy, divided by the magnitude of t, the derivative cubed, which is this guy. And that is the formula for the curvature. Let's move on and excuse me, do version 14. This time it's square root of 6 t squared, 2t so you do the derivative. So what do you get? 2 root 6t, 2 and 6t squared. So you find the magnitude. Now it's going to be 2 square root of 6t squared, 2 squared, 6t squared. And we're hoping that that'll simplify down. We shall see. That gets you 4, that gets you 6, so 24t squared. That gets you 4. And that gets you 36 t to the 4. I'm going to take this slowly. All I'm doing right now is rearranging them in order from highest to lowest power. What I've noticed here is that I can pull out a common factor of 4, so I shall do that. And then I notice that that's a perfect square. And the perfect square is a 3t squared plus 1 squared. So we end up with 2, 3t squared plus 1. And so if you want to find the magnitude of this vector cubed, you basically take this guy and cube it. So you get 8 lots of 3t squared plus 1 cubed. And we now have the bottom half of our formula. What we're now going to do is find the top half. Well, we know the first derivative. It's 2 root 6t, 2 6t squared. So we know its derivative. Oh, sorry, that is the derivative. We know the second derivative then is going to be 2 root 6, 0, and 12t. We can now find the cross product of the first and the second derivative. It's going to be an I, it's going to be a j, it's going to be a k. And we're going to have 2 root 6t to 6t squared, 2 root 6, 0, 12t. That's going to get us so many i's, take away so many j's, and so many k's. Okay, if you cover up this one, what you get is 24t take away nothing. If you cover up the middle one, you get 2 root 6 times 12, which is 24 root 6 t squared. Take away 12 root 6 t squared. And if you do the last one, you get 0, take away this number, which is minus 4 root 6. So we have 24t. That guy away from that guy has 12 of them. Take it away, so it's negative 12 root 6 t squared. And that end guy is just negative 4 root 6. Now the magnitude of this cross product is going to be the square root of each of these individual terms. So 24t squared minus 12 root 6t squared plus negative 4 root 6 squared. Right, 24 times 24 is just too risky for me to do in my head, so 24 times 24 gets me 576 t-squares. And that guy gets you 144 and that guy gets you 6. So 144 times 6 gets me 864 t to the 4s. And that guy there gets me 16 times 6. That guy gets me another 96. And so I'm going to look at this and see a rather amazing common factor, and that is 96. And while I'm at it, I'll put them in order. And so when I pull out that 96, I get 9t to the 4, which is good. I get 6t squared plus 1. And then I notice that the 96, I can kind of pull that out as a square root and leave this guy behind. And this guy is a perfect square. It's 3t squared plus 1 squared. And 96 can be simplified. It can be simplified as 4 root 6. And this guy can be simplified as 3t squared plus 1. So we now have the second piece of the puzzle. So to get the curvature, we take the magnitude of the cross product of the first and second derivative, which ended up being remarkably nice, and we divide it by the magnitude of the first derivative cubed. Okay, well, the top guy is 4 root 6, 3t squared plus 1, and the bottom guy was 8 lots of 3t squared plus 1 cubed. And there's some cancelling going on there, some cancelling going on there. And you're left with, what's that? You're left with root 6 on the top and 2 3t squared plus 1 squared on the bottom. And you now have your program. It's actually surprisingly nice considering what it could have been. Let's do one last one of this kind of situation. Let's see which one I can get. Let's do let's do this one. So this one is a version of question 16. The guy that we're going to use is the space curve 3t squared log of t log of t. And we're going to be asked to find the curvature at one particular point. And the point is 3, 0, 0. Now, although we're going to be finding it at one particular point, we're still going to go through basically the same process. And then essentially at the end or close to the end, we will then incorporate this number. I would probably do it closer to the end. So the fact that you're given a point and not a t-value means that we have to figure out what the t-value is. And if we match this one, it could be plus or minus 1. But when you match it to these ones here, it ends up being 1. So this is the equivalent to t equals 1. So you can think of this question as being find the curvature at 1. So we're going to start by getting the first derivative. 6t, 1 over t. And this guy's going to be a product rule, so it's going to be log of t plus 1. Now the magnitude of this vector is going to be 6t squared plus 1 over t squared plus the natural log of t plus 1 squared. Now at this point, I think it would be helpful to find the value at 1, because that's the only one we're really interested in, right? So the value at 1 is the square root of 6 squared plus 1 squared plus 1 squared, which is 36, 37, 38. So it's just the square root of 38. And so the magnitude 1 all cubed is the square root of 38 cubed, which is 38 square root of 38. Now moving on then, what do we know about the second derivative? Well, if you differentiate this guy, you get 6. If you differentiate this guy, you get negative 1 over t squared. And if you differentiate this guy, you get 1 over t. And we will now find the second derivative at 1. And that's going to be 6, negative 1, 1. So now we can find the cross product, and we'll do it at 1, of the first and the second derivative. So that's going to be an I, a j, and a k. And the first derivative at 1 would be 6, 1. The log of 1 is nothing, 1. And the second derivative at 1 is 6, negative 1, 1. So the cross product, so many i's, take away so many j's, plus so many k's. When we cover this guy up, you get 1, take away negative 1, which is 2. You cover this one, you get 6, take away 6, which is 0. And if you cover this one up, you get negative 6, take away 6, which is negative 12. So you end up with 2, 0, negative 12. So what I'm now going to do is find the magnitude of that vector. Right, now the magnitude of the cross product of the first and second derivative, actually at 1, not just at t. So it's going to be 2 squared, 0 squared, minus 12 squared, which is 4, nothing, 144, which is 148. Okay, and that ends up being 2 root 37 when you tidy it up. So the curvature at 1 is going to be the magnitude of the first and second derivatives at 1 divided by the magnitude of the first derivative at 1 cubed. And this guy is 2 root 37. And that guy is 38 root 38. Try to see if I can simplify this. Not really much. I could do, I guess, that cancelling. So that would give me square root 37 on the top and 19 square root 38 on the bottom. And we are finished. So that is how you do curvature using the alternate formula.